أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الاستاتيكا. درس اسمه تمارين على الازدواج العام. طبعا الازدواج العام احنا عارفين ان الازدواج ده لازم يكون فيه قوتين متضادين في الاتجاه وايكوال او يساوي متساويتين في المقدار، وبينهم بعض مسافة. بنجيب العزم الازدواج ونشوف المسافة ديت في القوة، بنقدر نحسب عزم الازدواج. النهارده هنتطرق الى درس جديد اسمه تمارين على الازدواج العام. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. It's called exercise about general couple. Dear student, look at exercise on the couple. Number 1. The side of square ABCD is 10 centimeter long. The forces of magnitude 50, 30, 50, 30 Newton act along AB, CB, CD, AD respectively. The two forces whose magnitude 40 root 2, 40 root 2 Newtons at A and C in direction of DB ray, BD ray, respectively. Find the algebraic measure for the moment of the resultant couple. Look at the solution. Dear student, we have a square. ABCD is a square. We know the lengths of each one, or lengths of all sides, are equal in length. 50 Newton act on AB, CD ray act on it 50 Newton. Also, two forces 30 and 30 act on CB ray and AD ray. Look at, there are two forces 40 root 2, 40 root 2 at point C and A in the opposite direction. What is the force which form a couple 30, 30? Then the moment of the couple equals negative 30 times 10. Why? Because moment of the couple equals the force times length. The force equals 30, length equal 10. It's sign negative. Why? Because in the clockwise direction. Then the couple is negative 300 Newton centimeter. This M1. We have another couple 50 and 50 act on CD ray, AB ray. Its moment is 50 times 10. It's positive sign. Why? Because its direction anti-clockwise. Equals what? 500 Newton centimeter. The force 40 root 2 and 40 root 2 also represent a couple. The moment of the couple equal 40 root 2 times 10 root 2, diagonal of square. Remember, dear student, if we have ABCD as a square, its side length 10 centimeter, then diagonal 10 root 2. Then the moment of the couple equal 40 root 2 times 10 root 2. Answer is 800 Newton dot centimeter. Therefore, the set is equivalent to resultant couple whose moment is M1 plus M2 plus M3. What is the sum? Is 1000 Newton centimeter. Another example. The rectangle ABCD is 12 centimeter long and 5 centimeter wide. The force 6, 5, 1, 7 and 13 Newton. act along the side AB, BC, CD, AD, and CA. Prove that the set of forces is equivalent to a couple and find its moment. Solution. Look at the student. From the opposite figure, we have rectangle ABCD. Look at AB. The force 6 Newton act in AB. BC, the force 5 Newton. Also 13 Newton act in CA. And CD 1 Newton, 7 Newton in AD. From the figure, there are no couple. For this, we analyze the forces 13 Newton in direction CB and CD. Look at the force 13 Newton we resolve on two axes, perpendicular axes, CB and CD. Compose the force along CB, we get 7 in direction CB, along CD we get 6. Now we got two couples, 66, then M1 moment of the couple equal -6 times 12 equals -72 Newton. The second 7 these are forces, two forces 7 act on CB and AD represent a couple, its moment 7 times 5. When, dear student, resolve 13 Newton at x-axis and y-axis, then 13 Newton on CB is 6, but is 7, but in CD is equal 6. Then we deduce that two forces in the direction CD and AB act in AB and CD, its force 6 Newton, then moment equal -6 times 12 equal -72 Newton centimeter. 7 its couple such as moment equal 7 times 5 equals 35 Newton. Then the set of the forces equivalent to resultant couple. M equals M1 plus M2. What is the result of moment of the couple? Equals -37 Newton centimeter. Another example. AB is weightless rod whose length is 100 centimeter. C and D are 2 points on the rod, apart from A by 40 and 80 centimeter respectively. The forces 300 F300 and F Newton acts on the point A, C, D, and B respectively in a direction perpendicular to the rod such that the forces at A and B are in the opposite direction to the other two forces. Find the value of F such that the rod maintain equilibrium. Look at the solution. Look at the student. AB, its length 100. C and D, C far from A equal 40 centimeter. D from B 20 centimeter. We have two forces F at two forces F at point C at B, and we have two forces 300 Newton and 300 Newton act on A and D. Then the two forces 300 form a couple. What is the magnitude? The magnitude of its moment equal 300 times the distance equals what? 300 times 80 equals 24,000 Newton centimeter. The two forces F and F form a couple, then the magnitude of its moment equals what? F times 60 by negative. Why? Because the direction of this couple is clockwise direction. Then M2 equals negative F times 60 Newton dot centimeter. Since M1 plus M2 equals 0, by adding the two moments, 24,000 minus 60 F equals 0, find the value of F equals 24,000 over 60 equals what? Equals 400 Newton. Another example, two collinear couples affect weightless rod AB whose length is 9 centimeter. The first couple is composed of the forces F and F kilogram weight, and the other of the two forces 2 and 2 kilogram weight, and acts as a point shown in the figure. Look at the figure. Find the value of F, which set is the rod is in equilibrium under action of the two couples. Dear student, look at the opposite figure. We have 2 Newton and 2 Newton represent or form couple, and two forces F and F represent also couple. Find the value of F, which set the rod is in equilibrium under the action of the two couples. Solution. Look at, dear student, we have 2 kilogram and 2 kilogram. This is the first couple, form a couple. Second couple, F and F. Draw FM extension and from C to make right angle perpendicular. The couple F and F equals M1 is equal F times 60 sine 60 equals what? 30 root 2 F. The first couple F and F. The couple 2, second couple 2, 2, its moment M2, 2 times 50 equals 100. Then the rod is in equilibrium. What you mean? The under two couples 100 equals 30 root 2 F. What is the value of F? We divided 100 divided by 30 root 2. Answer is 5 root 2 over 3 kilogram weight. Another example. AB is a rod of length 6 centimeter and waves 18 Newton at its middle. The rod may rotate easily in vertical plane around a fixed nail joint in a small hole in the rod at point C, part from A 15 centimeter. If the rod rests with its end B on the horizontal smooth table, while its end A is pulled by horizontal rope until the reaction of the table becomes equal to the weight of the rod. What is required? Find the tension in the rope and reaction of the nail given that the rod is inclined to horizontal by angle of measure 60 degrees at position of equilibrium. Look at the solution. Look at, dear student, the opposite figure clears that the rod is in equilibrium under the action of Number 1, the couple W and W2 forces. Number 2, the reaction of the nail. Number 3, the tension of the rod. Therefore, the two lateral forces will form a couple balance. The first couple, therefore, T equals R. What you deduce? 18 times 30 sine 30 equals T times 15 sine 60. By using substitution, then we deduce that T equals R equals 12. T equals R equals 12 root 3 Newton. Then T equals R, each one 12 root 13. Another example. ABCD is a plane pentagon. AB parallel to CE. AD perpendicular to AB. AE equal ED equal BC equal twice AB, each one equal 20 centimeter. What do you mean? AE equals ED equal BC equal 20 centimeter, but AB equals 10 centimeter. Measure angle A equal 120 degrees. Resolve force magnitude 5 root 2 Newton act along AD into two forces along AB and EE. If the forces 10, 5 root 7, 20 root 3, and 10 Newton act along BC, CD, DA, ED respectively together with the resolved forces, prove that the set of forces form a couple and find magnitude of its moment. Solution. Dear student, look at the opposite figure. Since F1 over sine 30 equals F2 over sine 90 equals what? 5 root 3 over sine 120. Look at F1 over sine 30 equals F2 over sine 90 equals 5 root 3 over sine 120. By using sine law, then F1 cross multiplication 5 Newton, F2 equals what? 10 Newton. Dividing the set forces into two groups. The first group, the forces of triangle AED 10 root 3. This first group. Then we divided each force by its length. 10 represent A acting in AE over AE, also 10 over ED equals 10 root 3 on AD equals what? Equals 1 over 2 ratio equal K equal 1 over 2. Then the set is equivalent to a couple C1 where its moment equals what? Negative 2 times half base times height. Area of base times height equals what? Negative 100 root 3 Newton centimeter. This moment of the first couple equal double half area, double area of triangle times K equals 1. Half times 20 sine 30 sine 120 equal negative 100 root 3. Second group, the forces of quad A, B, C, D. We divided the two groups. One represent triangle, the second represent quadrilateral A, B, C, D. 5, 10, 5 root 7, 10 root 3 act on AB, BC, CD, DA. Look at the ratio between the forces and side 5 over AB equals 10 over BC equals 5 root 7 over CD equals 10 root 3 over DA. By using substitution about its length equal 1 over 2, then find the value. Set of the forces form couples. Its moment equal C2 is 2 times area of ADCF plus area of ABCF. Look at the figure ABCDF. ABCD. This quad consists of two parts. The first part, triangle DCF. The second part is trapezium ABCF. If you find the moment of the couple, C2, we multiply 2 times area of the figure ABCD. This figure is unknown. Divided it two parts. The first part, area of triangle DCF. The second part, area of trapezium ABCF. After that, times K, or the ratio, equal 1 over 2. What is the K? The force ratio between the force and each side. Then we find area of the first triangle, half base times height, equal 100 root 3. The second area equal area of the trapezium, base 1 plus base 2 over 2 times height equals 150 root 3. Then second couple, 2 times bracket contains 100 root 3 plus 100 root 3 times what? 1 over 2. After that, C2 is equals to 150 root 3. Therefore, the set of forces are equivalent to resultant couple. Then C, or moment of the couples, sum of the two couples, C1 plus C2. What is the value of the moment of the couple? Negative 100 root 3 plus 250 root 3 equals what? 150 root 3 Newton centimeter. Look at, dear student, the figure ABCD. We divided it into two parts. The first part, triangle. The second part is trapezium. Dear student, in this example, this is very important. We have couples, but this couple is divided into shape is triangle and trapezium. If the forces are represented in three sides of any triangle in cyclic order, then the ratio between the force and the length of each side are constant, represent couple. What is the moment of this couple? Is twice times area of triangle times the ratio K. What is the K? The force F over length of each side. In this example, we have two couples. The first couple in triangle, the second in trapezium. Then we find area of a triangle and the area of trapezium. Area of triangle equal half base times height, but area of a trapezium base 1 plus base 2 over 2 times height, or half sum of two bases times height. Then we find the moment of the first couple by using 2 times area of a triangle times k. After that, we add the couples or the second couple in trapezium in cyclic order. Also, we find 2 times area of a trapezium times k. After that, we find the couple equal sum of the two couples. Dear student, don't forget couple equal forces in opposite direction, equal in magnitude, distance between them, the length. What is the moment of the couple? We find the force times the distance. We have two directions of the couple. The first couple is positive if the forces make anti-clockwise, but the couple is negative if the forces make with clockwise. Dear student, this couple or general couple is very important lesson. The couple in equilateral triangle, couple in any triangle, couple in a rectangle, represent a rectangle, square, trapezium, any figure, we can divide it into some geometric figures as a triangle and trapezium. Dear student, I am very happy to spend such time with you. Don't forget, math simple, think, work, produce. Goodbye.